Greetings, everyone. My name is Dr. Joe Shane, and I'm a chemistry and science education professor at Shippensburg University in central Pennsylvania. And it is my honor to welcome you to this online version of a course that is incredibly important to me, and I hope you find that it is important to you as well. It is literally the chemistry of the air, the water, and the soil, and how those three domains interact. And it's a lot more than just chemistry. But what I'd like to do with this introductory video is to introduce myself to you and overview the course. So this is not going to be an official lesson, although it does have the slides for the first chapter, but we're not going to start with this first thing with any kind of problem solving or lessons or anything like that. Just to give you an overview as a complement to all of the written and typed materials that are on the learning management software Desire to Learn, or D2L. So without delay, what I'm basically going to go through is my slides for my introductory information. You can tell I haven't rehearsed this a ton, but that's okay. We just want to kind of give an overview of the course. Um, and also just to introduce myself, because you never know when things that I'm interested in might overlap with your interests, or we have some kind of common experience in our backgrounds that may be relevant to the course or with our communications otherwise. Okay, so let's just go through a little bit of this. So a little bit about me, and this will save us some time when we actually get into the course. So who am I? That is me and my wife standing on top of a cliff. I forget where exactly we were. I think that was near Saratoga Springs, New York, when we were hiking. It was a hot day. I looked pretty sweaty. So that's me there. I'm from Western Pennsylvania. I grew up in Indiana, Pennsylvania. My mother taught at Indiana University of Pennsylvania. That's where I graduated from high school. Although I did live for part of my life in Mechanicsburg. My brother and sister both went to Mechanicsburg High School. If you're from Pennsylvania, that might mean something, both of those things. Um, if you need to know a little bit about my education, I went to the University of Delaware for undergraduate, and then to Purdue University for my master's degree, and then eventually back to Purdue University for my doctorate. And in between my master's degree and my doctorate, I taught high school chemistry north of Indianapolis in a town called Noblesville, Indiana, which was really a great time in my career. That's really where I made my commitment to public education and to teaching chemistry. And that's also one of the reasons why I have the job that I do. I'm in the chemistry department at Shippensburg, but I also have one foot in the teacher education department where I train science teachers. And I think I'm actually getting a little bit ahead of my bullet points here. And my wife, who's standing next to me there, is the director of development at the Bosler Public Library in Carlisle. That basically is an official title that she raises money. She's a fundraiser for the public library in Carlisle, where we live. I also have quite a bit of experience with German. If you're bilingual, I highly recommend that if you have the capacity to do that. I had my internship when I was in college with the Bayer in German corporation in Leverkusen. And I've kept up with my German a little bit, had my German on my original teaching license. So if you're fluent in German, perhaps we can practice together. So what do I do at SHIP? Well, you probably already figured that out based on what I just said before. So I teach chemistry to both science and non-science majors. We have various levels of chemistry. People that need just one semester of chemistry for a liberal arts class, I teach those. But then I also train middle school and high school science teachers. Lots of my former students are teachers throughout Pennsylvania and quite frankly, around the eastern part of the United States. And let's see what else. Oh, this picture here. I think I learned early on to put pictures on slides, not just text. This is something I went into my archives of photos from my first turn through graduate school during my student teaching experience. I actually did a demo show with a good friend of mine. He's still a good friend of mine. We did this for National Chemistry Week at Purdue for an audience of about 600 people, if you can believe it. It was a lot of fun. But that's just a blast from the past. You can see that I did have hair at one point. So other things I do at Shippensburg, science education policy, and I just should have put there science policy is an interest of mine. So many of you are going to or already work in an environment where law and policy impact what you do. For example, the Clean Air Act is the US law that governs air quality. So that's something we are going to pay a little bit of attention to in this course, but that's kind of an interest of mine. And then also science in public life. I do quite a bit of public outreach about science, and I have a little sort of sub-discipline, subspecialty, if you will, about interactions between science and religion. I teach an honors class on science and religion. I help to write a book for science teachers on how to address topics in science that have, for some people, religious implications. So if you're interested in that, let me know and I can talk about it. It's one of my favorite topics. And I do a little bit more with that than I'm letting on here, but it's not really directly related to this course. And also, we do quite a bit of outreach in the department to younger children, to elementary schools. In fact, we are now going to do our chemistry camp at Shippensburg University this summer. When I say this summer, I mean the summer of 2026, depending on when you're listening to this, which will be the first time since the pandemic since we've done it. But we've done that for years and we really enjoy it and think it is an important part of what we do as a public university. These might not be of interest to you. Professors always do other things on campuses, run committees, things like that. I'm on the university forum as of the year 2026, which essentially is the what do you want to put it? The overarching governance structure. Some places would call that a faculty senate. This is sort of the group that gets together to consider big picture decisions for the university. And then on a smaller scale, a lot of faculty are advisors for student organizations, and I'm currently the advisor for the men's rugby club. I played a little bit of rugby in college. When I was a high school teacher, I helped start a rugby club at the school and was the assistant coach. I wasn't good enough to be the head coach, which was fine. But if you're a rugby fan, we can talk about that. And then my personal interest, my main interest is road cycling. That's a passion of mine, is road cycling. I train quite a bit, so if you're into cycling, we can talk about that. Hiking, I'm also a volunteer for our local farmers market. And I don't know if you can see this. It's my T-shirt says "Herd Strong." That's the Carlisle Thundering Herd. I'm a member of the Carlisle School Board, so I'm an elected official. So I try to stay busy. I have quite a bit of volunteer work, but a lot of these things are centered around my commitment to public education and to science education. Okay, let's see how we doing here. All right. So enough about me. We'll get to know each other by through the course as you're listening to this. My goal with this course is not to simply upload a bunch of documents and a bunch of videos and then sit back and watch you do everything and never interact with you. That's not how I run online courses. So I'm not going to do that. This is really just to give you an overview of what you should expect to be able to accomplish. And also, I just realized with these PowerPoint slides with my face here, you're not going to be able to see all the images that I have. That's okay. This is just a cartoon. Sidney Harris was a science cartoonist. He did other kinds of cartoons for a magazine called The New Yorker for decades. He has a cartoon about every single science topic you could possibly imagine. It was pretty brilliant. And you'll look at this slide later without me talking about them. So what do you need to know? What is this course? And I put here tentative course basics because they might change depending on who signs up for the course, what your interests are, what your goals are. So it's possible that these would change, but I keep it pretty simple. So, well, here's the course. So we're going to start off with the chemistry of air, go to water, and go to soil. Now this is on the syllabus. I think maybe you can see this here. This is the book. I think this is the right edition. This is called Environmental Chemistry by Baird and Kahn. Baird and Kahn, never quite figured out how to pronounce that. Baird and Kahn. It's the 5th edition. I don't think this book is in print anymore with new editions. I believe the authors, I'm not sure if they've retired or they've done so many editions with the 5th edition, but this is a fantastic book. This is basically hits the sweet spot of everything you learned about in general chemistry: kinetics, thermodynamics, electron dot structures, physics, the physics of the electromagnetic spectrum, Roy G. Biv, E equals H nu, all those basic things you learned in general chemistry and then some in general physics are applied to the environment. So this is really a very, very unique book in that it covers the breadth of environmental chemistry, but does have some depth in it with mathematics and actual chemistry. So it's not a qualitative type book. This is a hard book to do, to hit that sweet spot, and they did it really, really well. It took me a while to find this book a few years ago. So that's the progression. And if you have the book in front of you, just if you've taken a look at it, that's the way the book is structured. During these lessons, these recorded lessons, not this one in particular, because we're not going to start that today, I'm going to emphasize the chemistry and then the physics. And then the way I teach chemistry is I tend not to give a lot of text on the slides, but I use a chalkboard or a whiteboard. We keep it simple here to do a lot of computations, a lot of diagrams. So hopefully a little bit of interaction. You're not just sitting and staring at a screen with my voice, but you're taking notes like you would in any science class and then solving problems and then seeing if you get the right answer. It's pretty simple. It's really the way I teach general chemistry, the way I teach any science class, but it's just a video. So that'll be the emphasis during the recorded lectures. There is a lot of information in this book that is not quantitative, that it goes through some of the biological implications of what we're talking about, pollution, ultraviolet light, just to name some examples, ozone. That's qualitative. I'm not going to spend a ton of time cutting and pasting text from the book onto a slide and just have you write it down. So some of that stuff you can just do on your own. You can just read about it, or I'll give you a link to an article or a link to some other resource that is helpful. So a lot of that you're going to do on your own. That also applies to things like laws, environmental laws, and then policies. And also I should have added there international treaties that are signed that give some framework for how we look at environmental chemistry on a global scale, and then some of the problems with that. But that's going to be mainly up to you, because you don't really need me to lecture that material. I'll just kind of be able to pick out the ones that are most relevant for you and then have you write about them for a homework assignment or make your own presentation like this. Okay, I already said that. The second thing, we have a free online chemistry textbook that we use for general chemistry. I think there may be an organic chemistry book too that's free, but these all fall under the heading of what are called OpenStax, OPENSTAX. You can see that there. So, and I should have put here, it's the second edition of OpenStax Chemistry. We won't use that a lot. However, before you start a lesson, say for chapter 1, which we're going to overview here in a little bit, is the book that, I keep putting my hand on the book. The book gives you a list of topics that you should understand before you start the chapter. Now, depending on when you had general chemistry, if you had general chemistry last year, that stuff will be fresh in your mind. If you haven't had general chemistry for 10 years, 20 years, if you've been out in the workplace, that's going to take you some time. So I'm going to structure this. So I'll tell you what topics you need to review, to remediate. The book tells you that, but I'll index that to specific sections of OpenStax Chemistry and point you in the right direction to some sample problems you can do to remediate yourself before you start the respective chapter from the environmental chemistry book. I should say, what did I want to say about that? Oh, yes. If you have your own general chemistry textbook that you used previously from another institution, if you didn't take your general chemistry here, that's fine. You can use that book. All general chemistry books really cover the same material anyway. But it's important that you do that before, because I am not going to spend a lot of time during lessons. I'll spend some, of course, but not a lot of time remediating all of those specific things. We're just going to assume that you understand those topics and go. And I know full well that will not be the case, that some of you will need some more time to remediate those things. See me during office hours to review it. That's fine, no problem, no problem. But I want to focus the course on the book. Okay, so how are you getting credit? So the main thing is there'll be problem sets with every chapter, not that tough. There's great problems in the back of the book, but I don't just assign those. I write some of my own. I write some Excel spreadsheet problems where I provide you a set of data and ask you to do some computations. That's a really useful exercise as well. Sometimes those are based on computations shown in the book. But anyway, so there'll be problem sets, and I'll give you points for your problem set. So chapter by chapter problem sets, something like that. Okay, that's pretty typical. Then I basically will give you a couple of take-home exams, and I think maybe, oh yeah, this is where it might be tentative. There also might be a final exam. When I taught this course the first time, and actually the only time prior to recording this video, it was face-to-face. And we just did a midterm and a final, and then you can see here, then there was a paper and a Zoom presentation. So that's tentative how we'll do that. And the take-home exams are really just big problem sets. They're really no different than that. And also the problem sets, since we're not meeting face-to-face, might also involve your taking a piece of the chapters, like say for biology, law, or policy, and doing a presentation for your peers using this kind of a format, or on Zoom when we meet during a acceptable time. So that'll be part of it as well, doing some kind of presentation on a topic that we're not covering in depth during our group, if you will, video lessons. The research paper and the Zoom presentation, the specific topics are going to be up to you, and I will tailor that to your interests. One possibility that I will do, there's a topic that I don't cover a ton in lecture, and that's the topic of global warming and climate change. Of course, that is a immensely important topic to cover. However, the science of global warming and climate change is not that difficult to understand. It's all based on what's called the greenhouse effect, which historically was called the hothouse effect. I actually like the hothouse effect better. I think it's a better phrase than greenhouse effect, but we'll stick with greenhouse effect. The science there is not that difficult. So what we may do, and this is again is tentative, is I'll have you each do your research paper and your Zoom presentation on that aspect of the course. Because quite frankly, you've been hearing about global warming and climate change for much of your lives, and maybe you already know the science. So this will just give you a chance to do a deeper dive and to sort out that topic for yourself. The book does have sections on global warming and climate change. It's an environmental chemistry textbook after all. But that'll also free us up to spend more time on the air, the water, and the soil. So some topics you might not understand as well. And that's what we'll tentatively plan on doing. But I will pivot and change that on an as-needed basis. Okay, I think that's it for the overview of the course. And I'm not starting a lesson today, but I do want to give you, so when you click on a video lesson and you're ready to go, what should you be doing? And I'll let you know, is basically be prepared to sit in a class like you're ready to go. And there'll be some supplementary handouts that I'll give you. Of course, you're probably going to want a periodic table. You're going to want a calculator. You'll want notes to take, however you take notes. And I'll give you the slides. I'll put those on D2L, but they won't have a ton of text on them. So some students download the slides and print them and then take their notes on there and then maybe rewrite them, or use the outline heading, because I use a very traditional old school Roman numeral, capital letter, lowercase number system, just a standard outline method for notes. It's not revolutionary. It's mainly to keep me organized. So some students will do that, but getting a little ahead of myself here. But so when do you need to take notes is, and I'll show you here in a few minutes. So let's just get into the course a little bit, but there's no note taking during this introductory video. Okay, so the first part of the course, so literally part 1 of the book, is, well, you can see it there for yourself: atmospheric chemistry and air pollution. I'm not going into the details there today. The only thing I would do today is, if some of this you may have heard about, is, and I put this question here, is, oh, that image, by the way, is from NASA. I think this is one of the space shuttle missions that took this picture as the sun was rising, and they caught this beautiful image of the atmosphere to show how thin the layer is. So this is outer space, and this is the Earth, actually. So it's all just black except for this thin blue line. I think maybe this picture was called that. I forget. I'm not sure. Is to show you how thin it is, but how vital what the chemistry that happens inside that thin barrier is essential for life on Earth and for a lot of the things that we talk about when it comes to health happen because of this layer. And I put on here, you may have a phone app. Here's my phone. I don't think there's any personal information I'm giving on the phone there. No. And you may have a weather app. So when you click on the weather app, it may tell you something about the air quality for that day. I recommend actually, I have an AccuWeather app, but I also have an air quality app from the EPA called EPA Air Now. So Air NOW. And it gives you well, whoa, hey there. Well, you can see it on your own phone. And it gives you what's called the AQI, the Air Quality Index. And for today, so when am I recording this? I'm recording this on Thursday, May 21st, 2026. And it says it's good air quality. It's actually raining outside right now. And it's really cool after a couple of uncharacteristically hot days. So it's in the green on the AQI. I mean, the air quality is pretty good. And that AQI, Air Quality Index, is okay, but it doesn't tell you what specific things are going on. You may have also heard of something called a No Zone Action Day, where you have an ozone alert. We're going to talk about that. And then things you're supposed to do and not do, like run an engine or don't spend a whole lot of time outside, especially if you're asthmatic. So take a look at your phone. See if there's anything on there about the air quality for where you are right now, just to see if you have something there. Okay, so again, we're not taking notes. I'll kind of show this to you today. So the chapter overview. The first chapter we're going to do, your first video lesson, will be stratospheric chemistry. I'm not going to define all this stuff now. And we're going to talk about the ozone layer. The second chapter are the ozone holes, a topic that was a great discussion when I was a high school and college student. There was so much discussion going on about the depletion of the ozone layer in the atmosphere. That's still an issue, but not nearly as much of an issue as it was 30, 40 years ago because of some good policies that were put in place. So that's chapter 2. So this is part 1, chapter 1, chapter 2. Then we talk about air pollution. Okay, that's basically all lumped into chapter 3. You might have heard about particulate matter. That seems to get in the newspaper quite a bit. Or PM 2.5, that's particulate matter that has a size of approximately 2.5 microns, which is also the same as a micrometer, 10 to the minus 6th meters. And then a chapter that I will largely put on you is the biology associated with air quality, so of pollution. So I'll do some of that, but not a lot. There's going to be some that'll be on your. So that's part 1 of the book. Okay, so when it comes to taking notes and you're ready to go, you've got a calculator, you've got notes, you're ready to do sample problems with me. There might be some supplemental information that I will send to you that you can print out. For example, a table of covalent bond energies, which I will provide you. You can look that up. You don't need me to provide it with you. A table of thermodynamic data that the only thing we're going to need from that is what are called heats of formation, which is a little triangle, delta H. It's German, it's Hitzung, but it's also heat. Delta HF, again, I'll provide a photocopied version of that table from a textbook, but you can find a table on your own. So you'll just kind of want that information there to write notes and do sample problems with me in class. And if you have a periodic table, I will often tell you to put information on the periodic table or on the back of the periodic table, like formulas and constants you don't need to memorize. And I should have said this before, and this is where I think I missed this. I look at chemistry for this course as a tool. This is a chemistry class, but chemistry and the math these are tools that we need to understand the environment. When you took general chemistry or organic chemistry, it was a lot of material that you were learning kind of for its own sake. Of course, we had applications of the chemistry, but here it's all applied. And the application is the air, the water, and the soil. So I'm not going to do a lot of theoretical discussions of where these principles come from. They are tools that we need to use to understand environmental chemistry. Okay, so just to give you a sense, this is just an overview. I'm not starting the notes here. Roman numeral 1, chapter 1. Okay, there you go. And basically the way I do this is I have headings and I'll put an image over here. This image is pretty similar to the one in the book. I just thought it was better. I'm not going to go through all this right now. And then my slides, you'll see my slides don't have a ton of text on them because I just use slides for the basic text, some summary information, like I paraphrase it as tightly as I can. You can go to the book to get a more extensive explanation of topics, but I spend time in class going over problems. So just writing down, if you have these slides, and the way I'm planning on doing lectures, I've tried so many different ways of doing this, like saying recording PowerPoint slides while I have like a stylus and I write on the computer screen. I don't like that method, and students didn't like it either. They didn't like it when they just saw this hand on the side of the screen writing. I am very uncreative when it comes to these, but it seems to work. I just have a very basic camcorder. I will have a camera with me in front of a chalkboard or a whiteboard. And I tried doing something where I had the slides like off to the side on a screen. It doesn't record very well. So I'm not going to do that either unless I figure out a better way to do this. So what I'll ask you to do before a lecture is download the slides. When I'm doing the lecture, I'm going to have the slides on a computer that I can see, but I'm not going to have it. I'm not going to try to record the slides and the whiteboard with a freestanding camcorder. It just doesn't look right. And I think it's really distracting. Plus, I'll just give you cues on what to look at. Like when you download these slides, I'll make some references to this picture. You won't actually need to see them when I'm lecturing, but if you have them in front of you on your computer or you print them out, that'll be enough. We did that for 2 years during the pandemic. For general chemistry, that's kind of how I taught my lessons, and the students actually thought it was just fine. In fact, I still use the videos for when students get sick or they have to miss class for some other reason. The videos are fine. The videos are fine, and they're very basic. But I think students like it because it gives you the feel of a classroom. It's not perfect because it's just me on a screen, but these videos are for you. I'm not looking to make a bunch of money with these or anything like that. So, and I'll provide you links for all the videos. So like you'll see a link for this one. So just to see how, so this is where you'll start taking notes, essentials, relevant chemicals, and selected properties. Then I'll do a bunch of structures here and talk about properties. That'll be like 15, 20 minutes. Then there's some text that explains this, like some summary, like what is the atmosphere? Okay. So this will be a lot of just text, and then this image helps with that. And then there's a bunch of images. These are really cool images, by the way. I think these are similar to the ones in the book, but I tried putting the camera up. These slides just don't appear very well on the camera, so it's almost pointless to do that. So you can see there's no notes to take there. Those are just things to look at, make notes on, but you're not going to record all of that. That's why you have the image. You don't have to record all of it. Oh, and then we'll do some math. There's another graphic for the electromagnetic spectrum. I'm not going to go through all that. And then you can just see how much text there is. Then we'll just do some problems. Frequency, wavelength, where does the wavelength fall, all that good stuff. And then go through some math problems. Okay, I don't want to insult your intelligence here. So the slides don't have tons of information. I do not just make videos like this and sit here and read slides to you. I don't do that. The vast majority of our time on the videos will be doing math problems, doing chemistry problems, one and the same. Okay, I'm not sure what else I need to do here. So yeah, there'll be examples underneath of all this. Yeah, and then we actually get into some of the ozone stuff.